All right, welcome back, everybody. Thank you for joining us today. As it was mentioned before, it is a follow-up of the session that I did already almost like 2 months ago, but who's counting? And a lot of things that I will be like starting off, they not will be out of the blue. If you miss some of the points that I will be, talking or something is confusing, you can always get back to the previous. There's a video, there's the time codes. Code is available. So whenever it is required, I will be, calling back to the previous one. So on the previous one, we focused on installation and getting started, how you can install control plane for Kuma Mesh. As a matter of fact, the Kong Mesh use the same, it's just a different binaries that you need to be using. Use the same procedure to install all those things. With the we install the applications. We play around with basic functionality that is available. We enabled observability so we can see the traffic. And today we're going to be focusing on enabling certain policies in order to do some of the traffic shaping for our application. So I hope everyone can see my screen right now, and it would be great if I can get the like a thumbs up in the chats. So before we proceed, that everyone can see it, can hear. Everyone is excited. Everyone, I'm excited. So write down in the comments if you are excited. So the quick reminder how everything works. First of all, source code and all the things that I will be talking today is available already on the GitHub. There is a folder about workshop you can follow through. There's just like a steps to follow. There's source code for the apps, source code for the policies, and all the things I will be talking today. If it's not there yet, it will be published by the end of this session there. So make sure to bookmark this URL. That's going to be my GitHub where you can find this. So in the previous session, I showed you three simple things. I show what I do at work, and there's an application that when I invoke this, I will go to meetings. And many of you, if you've been on the previous presentation, you know that meetings are so excited that it's a good time spent there. Couple things about two applications. So this work application will call this meeting endpoint 4 times and aggregate response in the form of kind of like how much time it took me to do some work. And inside my meeting application, I do have a classic the classic function that allows me to simulate some work. In this particular case, thread.sleep, and for 250 milliseconds. So in this case, 4 times 250 milliseconds will give me 1 second. So every call between my work application and my meeting application will take exactly, not exactly, roughly 1 second. So to demonstrate this, this services runs inside Kuma Mesh, and also we used functionality that is built-in inside Kuma Mesh called a Mesh Gateway that allows to expose this application to outside world. So if I will go, you actually can try this yourself. If you have a handy tools like Insomnia, you can go and fire this up and just start kicking this Kong Mesh. Kong.me.sh. You can read this as a Kong Mesh /work. You will get the result something like this. Went for 4 meetings, and it took me roughly 1 second or 1,000 milliseconds to do this. So there's a lot of things going on with this one simple request. And from to remind you the powerful features that are available inside the mesh, I remind you about the observability bits. So my applications already deployed inside the mesh, and I enable some of the tracing and logging and the metrics collectors enabled in my application. For those of you who missed this, we did this last time. I'm not going to spend much of the time this. Grafana is deployed, and inside the Grafana, let me quickly refresh. It's still fresh data. This was drawn by hand by Viktor. but this one automatically generated based on the tracing data available inside service mesh. So this our mesh gateway, it sends requests to our work application, and the work application will invoke our the meeting application. If I want to just discard this, if I want to go and see a little bit on tracing side of things, and if I want to see service, say mesh gateway, and see all operations from within, let's do last 5 minutes. We have this trace because I first time called this and this trace went in. And with this nice UI, you will get a breakdown what is happening with this application. Again, everything I just explained to you using this diagram actually can be retrieved from within the service mesh. As you can see here, one call that happened between my application actually will be resulted into the 4 calls to my work application. So this is quite powerful, and as you can see here, you get the timing. You have this the 250-ish milliseconds. We also need to attribute some of the network latencies around and all this kind of jazz. So that's what we're going to be working with. So we're going to be I didn't have much time last time because we were limited by duration of those sessions. We want to be mindful about the time of the people who joined. So I didn't spend much of the time exploring some of the policies that is available for you to do different, like a traffic control things, or traffic modification, or maybe even fault injection things inside this application. So we're going to be dealing with this. We're going to be using same tools. We're going to be using tools that are available for service mesh to explore service mesh, and maybe even try to discover some of the failures. So in this particular case, this is trace that represents the normal flow of our application. So normal flow of application: one request goes to gateway. From the gateway, it goes to my the work application, and 4 calls to my meeting application. Does it make any sense for everything that I'm talking about? Write down in the comments. Let's see if the thing is still working. One of the first things that you usually want to enable between your application, you want to make sure that communication between system is secured and encrypted. And that's why if I'm switching to my the Kuma manager, that's the UI that is available as a part of control plane. In the previous presentation, I also show how you can enable this. You can always find the way how you can enable this in your application. So I have a default mesh, and many of you might notice this this notification, the bell here, over here inside the inside this this UI, this guy, this little fella. So this little fella wants some of the attention. Same way as I want some of your attention when you go to Conk YouTube channel. You need to make sure when you went to Conk YouTube channel and enable all notifications here. And you also will have notified when we're going to publish some of the recordings of this meeting, or some of the content that also relevant in the world of API and in the world of Conk. Speaking which, since I already have you on my YouTube channel, on our YouTube channel, on Conk YouTube channel, sorry, I want you to pay attention to this quick video. So we announced this week, we announced the 3rd annual virtual hackathon. That would be a part of our bigger month of different cool activities that will be leading towards API Summit. So this year API Summit is virtual. We have already announced the lineup of the speakers. We have announced the lineup of the guests who will be there. And also we announced the 3rd annual virtual hackathon. So if you go to API Summit webpage, you can get a register now for that's you should do to register for API Summit. And also, if you have some cool ideas naturally, you probably guessed it, this year is all about AI. And we also making AI as a theme for our virtual hackathon. If you have some ideas around AI and APIs and all these things, we want your submission. We do have prizes. We have a 4 prizes for $250 gift cards, and the top, the winner, will get a $500 gift card. So that's pretty exciting. So sign up today for virtual hackathon. You don't have to like submit immediately. Just sign up and get news and updates, but make sure that you send your submission by the end of September 26th, because we're going to be first day of the API Summit is going to be September 27th, and we're going to start announcing the winner. So sounds cool. And I will paste this inside our chat if you want to explore. So when we took this out of the way, so you know that notifications is good, YouTube is good. Now it's time to click this notification. So it was a little bit on the build up the some of the drama for this, and we can see, as I mentioned in the previous sessions, and every time when we talk, and when I like to talk about Kuma, I like to say that Kuma is always trying to provide the best developer experience. And one of the ideas for this developer experience is that we're providing you guidance, what you can available or what you can enable in your service mesh. In this particular case, I have a cool things like a tracing, login, observability already enabled, but it says I don't have zero trust security enabled. If you're not familiar with the term of zero trust security, that's the concept that build up on the different pillars, that is architectural patterns, how you're thinking about security. So zero trust security is the idea that you cannot rely on traditional ways how you can say that, yeah, this is the safe caller or it's not safe caller. You need to come up with ways how you can authenticate, and especially it would be beneficial if you can do this like automatic fashion. One of the pillars of zero trust security that is Kuma Mesh enables is a mTLS. So we're going to be enabling mTLS, mutual TLS, between the components of our system. Also, when we're looking at our mesh, you can see that the mTLS is disabled. So it is easy to fix. For those of you who don't know how to do this, there's always a link to documentation. Looks like a link is broken. We need to fix it. But inside documentation, it should be something like mTLS. Now we're going into policies and mutual TLS. So this is a quick explanation what it does and how it works. We're going to be using built-in certificate authority that is a part of control plane. This will be issue certificates and will be distributed those certificates across data planes. So that's what we're going to be using. If there's also integration with the existing the certificate authority, the mechanism, you can read how it's done. Kong Mesh provides even more extended version of this, like out-of-the-box integration with the Amazon or HashiCorp Vault and so far so on. So we're going to be, for this, for free and open source version, we're going to be using built-in CA that will allows us to just like create self-signed certificates inside our mesh. It will be already good enough for many use cases. So enabling mTLS is quite easy. So I'm going into my mesh definition. Again, the source code of this file is available on GitHub. You will be able to explore it yourself. Now, I do have a mTLS section of my mesh definition is commented out, and I'm go ahead and uncomment this. We have a backend. In this case, type is built in. Certificates expiration 1 day. It's going to be using 248 bits encryption. So if I go to my mesh mesh YAML. I apply this policy, and inside my mesh, we immediately see the services are protected with mTLS. The cool thing is that all this configuration for the mesh, as you can see here, is also available to you to see like inside UI. So you always will see what is changed, what is like new and exciting inside here. So as you can see here, we have a Jaeger collector, logger, and mTLS enabled. There's a in Conk Mesh, if you will be using Conk Mesh as a deployment here, there's a more extended UI also available. So you will be able to introspect some of the certificates that are, you can see like expiration of the certificates and so far and so on. So let's see if our application is still working. So while we enable this mTLS, now everything is working because everything is part of the mesh. What I like to show in the past, if I will be using some of the tools not a part of the mesh, for example, I like to use the conk as an example when the conk gateway was not a part of the mesh, and the connection between conk gateway into mesh was broken because conk gateway was not a part of service mesh, and the connection between the conk gateway to mesh was not secured. There's another example that we have on our YouTube channel where you can find how we can protect the, say, like a Postgres database that was a part of the mesh, and the client that was connecting to this Postgres database were not a part of the mesh, so the certificates were not issued for this, so the mutual TLS connection will not be able to establish. So those things are failed to connect. So now everything still works. Everything is great. Everything is awesome. There's another trace that just happened, and it didn't increase much of the latency between the systems. Again, like maybe like if we will try to do like some extensive benchmark against this service, we will get some of the some of the results in encrypted versus decrypted traffic. But for now, like as you can see, there's like not so much is going on. So that's the mutual TLS enables very quickly, and more importantly, control plane will be responsible for rotating those certificates. So one of the pillars of the zero trust security is that rely on eliminating not only trust but also eliminating a human factor. Every time we need to do something manually, it will most likely will lead some errors unless you have a very well-defined instructions. If you have a very well-defined instruction, why don't you automate those? And that's what exactly piece of automation that the control plane is taking to cover this. Now, let's take a look to policies now. When you deploy mesh, some of the policies are already deployed for you and available by default. One of the things that I want to show you, for example, a retry policy. When you deploy your application, there is assumption that you might deploy this in Kubernetes, and this Kubernetes cluster might be the part of the public cloud, and you don't have like a full control over what is available and what's the network latency. So you might want to before kind of like a failing because of some of the network issues that are available in your cloud provider or that happened in your cloud provider. The thing is with this policy, it is out of the box enabling some of the things to make sure your application is continue working. So one of the things that you can see here, there's a number of retries, timeouts, and it's not only available for HTTP traffic, for L7 traffic, but also for gRPC. If you Kuma supports managing those things as well. And those things available out of the box. So it is time for us to play around with some policies. Again, always you can always find enabled policies over here on the overview of the mesh. Like you can always see what is enabled inside gateway. One of the inside the service mesh. Trace policy allows to have a communication between multiple nodes to be captured. There's a gateway route from mesh gateway into work application through the prefix of the slash the destination. So you will be able to also with this gateway, you will be able to configure different backends. You can have a different weighted traffic and can have a blue-green deployment with different weights for your applications. Now, let's talk about rate limiting. This is quite quite a topic. I don't know if you're following this popular social network called X. I used to know as a formerly known as a Twitter. And I also there. You can follow me in this social network. I'm a quite interesting person. Rate limiting. Couple weeks ago, there was all of a sudden reports around people cannot post because they were rate limited through the things that they cannot post, they cannot retrieve tweets, and rate limiting is the one of the approaches how you can protect your system from being overwhelmed. So let's enable this. We're gonna put rate limiting policy between my services and specifically in front of my meeting service. So request rate, I would specifically put request rate with 3 because we know that everyone will be issuing 4 requests. So we can see how this policy will work. It will send status 423, and it'll add header that it was rate limited. So let's try to enable this. It's called mesh rate limit. So again, if you're looking into UI, you can see there's a mesh rate limit policy. And always you can see what is a data plane. Why it's not? Meeting service. Yeah, it's a wrong one because it is a devs. Yep. Let me reiterate this. And now, so that's the cool thing is that within UI of the Kuma, you know, if you're trying to debug if something is not working, you will be able to always see, you apply the policy and see what kind of services will be affected by this policy. So in this case, we see this data plane was affected. And now let me try to see when I submit request, I went to 3 meetings now. So what happens is we're trying to send 4 requests, but we were rate limited by 1 request, and now we get response from 3 meetings. Let's take a look inside our trace, what our trace will tell us. That's going to be the more fresh one. And yes, indeed, we see, let me see if we can have a new trace, because it's supposed to be one call. The one last call, as you can see, this call went for 1 millisecond. So it went to data plane proxy that deployed alongside with the meeting application, And after that, we get the response. Do we have any logs? I want to see if we can, how I can show you if we do have. So when I go to, where's our views that are available? Kuma service. And in this particular case, I'm interested in our meeting service. And I'm interested in if we can have different. Oh, yes, I can. I know how we can see this. So inside here, somewhere inside the traffic, we should be able to see. I'm wondering if we need to do this like a little bit more, like the last 5 minutes and refresh. If I will generate a little bit load, a repeat on interval, say every second. That's my approach of submitting. Now we start seeing that you see, it's a real time. The sliding window for interval was 10 seconds. So within 10 seconds, you will be able to only issue 3 requests. Also, we also will be able to see, where is the response code? Because I see here, we do have a error rate. Yes, if it's color coded. Green one is 200 and orange one is a 400. So now we're getting a 421 as a response. And also, let me stop this. Inside some of the logs of my application, I also print out headers. If I go to my Loki, and we'll see applications from work within the last 5 minutes, run query, show logs. Let me see if I can show you that my headers are printed out. So no, it is supposed to be on the meeting. Oh. Browser. Let's do meeting. Run query. Show logs. So every time when the request comes in, I log this request, and I know that's a user agent that is hitting my message system. And what I'm looking actually here is Kuma rate limit header. So we go on older logs, newer logs. We should be able to see something like the bunch of headers were provided by Envoy. As you can see here, there's like a tracing headers. I'm looking the let's see if it's the rate. Can we see this? Supposed to be adding this header here. Need to investigate how I can get this information outside of the logs. Maybe some cool query, but the thing is, thing was working with the with our UI. So let me remove this rate limiting for now, because we will continue. So you can have different policies between different services. Here's one important thing to point out. I did mention this in the very beginning, and I should probably. So starting from the, I guess, Kuma from 2.2, we start introducing a different syntax for defining some of the policies. There's the old style of defining those policies, and there's new style. And I'm trying to follow with the new style, and it's called mesh rate limit. If you go to documentation, you can find there's a rate limit which is old style of defining the of the policies for the rate limiting. And also there's a mesh rate limit. So mesh rate limit is a new way, and right now it's the it looks like it says it's a beta version, but going forward, all the policies needs to be converted to follow the new style. Also, it's not very good idea if you will be mixing and matching the old style and new style. That can lead you to some of the conflicts, and some very terrible things might happen. Also, very important to understand that there's some policies are the way how they will be, applied and stuff like that. So we need to know how the matching would work in terms of like how the service will be working and all these kind of things. So that's a very important thing to point out. Okay. Okay, so there is a question. Let me. Under the covers, are two methods still working with the same filters in Envoy, or is different? It is the same underlying Envoy capabilities, but we found we need to have a better way to expressing certain rules. So that's why the new syntax will be it will be more powerful in going forward. But underlying technology still will be using like Envoy filters. Yeah, thanks, Randy. Now, with rate limiting. Now, let me remove this. One important thing to point out, if we go to Kong Mesh, Kong Mesh introduced a new policy with the global rate limiting, and allows you to have a rate limiting on the mesh side of things. So it is it's described in documentation how it works. I probably need to take another maybe either it's going to be Con Builder stream to talk a little bit, because there's a lot of interesting things going on here and how these things would be different between the global rate limiting versus the local, just the standard rate limiting, and also how this will allow you to configure and prevent from denial of service type of attacks. So that's it's another thing to point out. I think someone wrote even a blog post explaining how it works. One of the engineers from the Conf Mesh. So there's a lot of things to choose from. Now, so rate limiting is done. Now let me quickly talk a little bit about another cool traffic policy before. Let me quickly remind myself what we were talking about. Yes, we talk about retry. I will show you how we can do the fault injection. Let me do this right now. So fault injection, it's another interesting. It is another interesting. Yeah, so it's another interesting policy that allows you to do interesting things with your mesh. Specifically, this one allows to inject specific type of responses to the service. So 50% of requests that will be happening between work and meeting service will fail. So result, let's see if it actually works. We still have 4 meetings, so we're back. In my we're going into Jaeger. We're going into Jaeger. Inside the Jaeger, we sure search mesh gateway. Last 5 minutes. And now everything works. Like all the 4 milliseconds works. Now, let's inject the failure here. So when I will hit this, I will get at least 2 meetings, 3 meetings, 2 meetings, 0 meetings. Sliding window that happened between the systems. So for Windows. So let's take a look. One of the things. And immediately we see there was a error, and we know that 500 is not good, and we'll be able to. Why we don't? I don't know. Like why I cannot see logs right now. They're supposed to be seeing the logs from this span. Maybe. Yeah, this error. Let's see if we can see the log from here. No. So in this case, the failure was injected by mesh, and yeah, I'm surprised that I cannot see why I don't see logs. I need to check my config. Yeah, response was 500, but this response was oh, this is how I can see the different headers, right? So the response came in from proxy. So the response came in not from my service, not from my application code, but actually from the data plane that sits between my application in this. Why you want to have this? Like why you want to inject failures inside your application? Do we have any kind of like in the chat? Are you still with me, or I lost everyone completely except Randy, because Randy is a friend and he is supporting me along the way. What do you think we want to have a false injection inside my application? Also, I'm drinking today drink for DevOps people called uptime. You know, you want to have a infinite uptime. No idea. So we have I hear crickets. One of the practices of DevOps is if you wanted uptime, prepare for failures. Or like if you wanted to peace, prepare for war. Same thing here. One of the practices to validate if your system is resilient for type of issues that might happen is intentional injection of the failures. There is a category of the software and the category of DevOps practices called chaos engineering. Is that where you actually injecting some of the failures into your system to make sure that your, say, monitoring and your alerting systems can capture this. So if I go to, not this one, I'm going to Kuma Mesh, and let's see real-time update, send, repeat on interval every second. We'll start, and we should be able to see last 5 minutes. You see now it's gonna red. After few seconds, I would say this thing will be balanced. So we will see 50% of failure rates. So we have an assumption that, say, I might have alerts configured in my dashboard saying that if the 500 errors start happening, I need to start sending notifications. I need to notify my SRE team. I need to send emails and things like that. So you want to test your production system in situations where some errors start happening. You want to test your notification system. You want to test your how good is your like a monitoring and notification system. You inject failures and see how the system will react. Some SRE engineers call it like a game day scenario. Like you have a certain assumption that might happen in your game day or like the biggest day of the year for your business. So you program this, you test for this. So when the things will start getting out of control, this is where you will be prepared and saying, yes, our monitoring system can capture those failures. Our monitoring system can detect all these things. Okay. Let me also remove this. And YAML. So we will remove this problem and get it back. And now let's talk a little bit about the concept of discoverability. Since I'm deploying this inside the Kubernetes, there's a very well standard ways to configure discoverability of my applications inside the Kubernetes. Specifically, there's certain DNS rules that are available, so your system will be discoverable. Why it is important? Remember, my two services, they are depend on each other. So my work application is depending on the meeting application. So meeting application URL needs to be injected somewhere. So let me show you quick code how this looks like. I'm looking into my work deployment, and my meet URL will be injected here as like this. So why does it work this way? So two services, they deployed inside Kubernetes. They deployed in same namespace. So in this case, I can just simply use name of deployment. I'm not using name of the pod because of the name of the pod might change. So I'm using name of the service. I have a service, load balancer service, in front of this as my my meeting application has a service built in, and in this case, I can put this in front of this. Now, since we're running this inside service mesh, those two applications can be deployed in different namespaces. But since they're part of the same mesh, we actually can do thing like this. So service mesh, inside the service mesh, you have a predefined the domain name .mesh. And this application, this meeting application can even be deployed in a separate cluster, cluster that is a part of the same mesh. So discovery will work in this particular case. So if I will go and say make a demo app install, update this. Okay, I'll just do Kubernetes apply, and we're going into folder Kubernetes. Oh, snap. Different namespace. And I'll just apply minus namespace mesh for devs. Okay, so we only configured the work deployment, and let's see if our connection still works. I'm switching back to Insomnia. Oh, let's do this. Cancel. Still works. Oh, no. Internal server error. So in this case, something went wrong with the. Let's see if the deployment is up. And let's go into namespace for mesh for devs. Pod is terminating. Pod is running. Our meeting application is up and running. So we should be able to get a correct response. So we're still getting error. Let's see why it's not. Work. So it cannot. Unresolved host. That's interesting. That's interesting because I need to redeploy work application because the previous version of the previous configuration is there. So what I need to do, I just need to redeploy work application. So the new configuration will be injected inside my work application. Application is up and running. And when I run this, still not. Why not? Should be let's do what we always do. Uninstall and install. Always works. For the sake of time, I want to clean up this quickly rather than trying to discover the problem. So once again, what I wanted to do here is to, where is my documentation? So documentation, I want to say dot. Do we have it? Networking, DNS, service discovery. Yep. So with the service discovery, yeah. So the Kuma creates mesh zone for native for this. So this is what I wanna try to do. Make demo app install. All right, so deployed. Let's see if my work application is still working. Cancel request. I think we're waiting for something. Let's see if we can. Work application is up and running. Server is running. My meeting application. Meeting application is up and running. So maybe I need to redeploy. I need to redeploy gateway because it doesn't seem to be. Let's see if the services are back. Yes, services are back. Gateway is done. Okay. Okay. Gateway is up and running. So let's see if the cancel request. I'm wondering if gateway was provisioned with the same with external IP address. So we need to wait for a second. So we redeployed the services, and the gateway lost connection to the service. Now we're waiting until this gateway would be reprovisioned with the external IP address for our application. Yep. And in this case, let's see if I'll just do dig. $98. So lucky us, Google Cloud kept our IP address. So it's still internal server error. So I cannot. I think I'm messing something here. I need to discover this. But the thing that I wanted to show you is called a VirtualOutbound that will define a rules that will do correct routing. So in this particular case, I wanted to have like everything that will go into the service will go to the service.mesh and will be routed to the port 8080. So whenever my application will be deployed, so let me kill this guy and put the this guy. So whenever my application will be deployed inside the mesh, it will be discovered. Like, let's see. Hopefully it will. So I'll just do mesh slash vo. So we deploy virtual outbound. Let's see if my virtual outbound is configured. So if I'm going to my mesh default and virtual outbound, and we'll see the affected data plane proxies. Why it's not showing me what kind of services it will be? It should be all services, in my opinion. So I will deploy my virtual outbound okay. So work deployment is picking up. Okay, let's see if it works. Let's see if it works. Now it works. So I installed this virtual outbound rule. So it is maybe not so super kind of like a clear how this would be beneficial if you deploy this in this like a simple setup. But Kuma is designed to be run in a multi-zone, like a the multi-environment mode, where the Kuma provides unifying the ways. And with configuring the virtual outbound, so my meeting service will be discoverable everywhere inside the mesh by every service. So instead of knowing what's going to be our correct port, what's going to be our correct if it's different namespace, it's going to be meeting dot clusters vc, the namespace clusters vc dot local. It always will have this name from within the mesh. So we're going to be able to connect to this service. So that's the virtual outbound. Think about virtual outbound if you are in a network nerd and to know a little bit from the past. Think about this as a NAT. You're creating this virtual bound as a NAT service that will be protecting some of the services. One of the benefits of using virtual outbound, I did show, like, also there's some video on YouTube on our YouTube channel that talks about deploying Kafka inside Kuma mesh, and the virtual outbound helps to do this kind of like discovery. So the Kafka within the mesh would be available as a kind of like Kafka.mesh everywhere, knows where the Kafka is. So same thing here. So let's do recap. I showed you different policies available. There's a ton. I couldn't possibly show you everything. There's a tons of the things, and plus some of the new things and the new syntaxes. We didn't talk about health checks, HTTP route, and things like that. We talked about rate limiting, retries. Some of the policies were available out of the box for tracing, for capturing logs. You also saw how observability works. I hope that was something that would be beneficial for some of the work that you're doing in your real life and your professional life. So with this, my name is Viktor Gamov, and as always, have a wonderful day, and we'll see you around.